Dear students, today we are going to discuss a very important topic of differential calculus, that is Lagrange's mean value theorem. So let us look at what is inside Lagrange's mean value theorem. If you go through the historical fact of Lagrange's mean value theorem, then you will be happy to know that this theorem was the special case of this theorem was first described by ancient Indian mathematician, and the name of that mathematician was Parmeshwara in 13th century. In his commentaries on गोविंदा स्वामी एंड भास्करा सेकेंड में इन्होंने बहुत डिटेल में इस थियरम के प्रारूप के बारे में हम सबको बता दिया था। इस प्रमेय के एक विशेष भाग की चर्चा सबसे पहले हम सबके प्राचीन भारतीय गणितज्ञ परमेश्वर ने की थी। तो ये शायद बहुत कम लोगों को पता है जो लैग्रेंजेज मीन वैल्यू थ्योरम को यूज करते हैं, पढ़ते हैं, पढ़ाते हैं, कि इसकी परिकल्पना सबसे पहले हमारे भारतीय गणितज्ञ परमेश्वर ने 13वीं सेंचुरी में ही कर दी थी। इस थ्योरम का जो बेस था वो उन्होंने दे दिया था, जिसकी विवेचना उन्होंने अपने इस ग्रंथ में जो गोविंदा स्वामी नाम से जाना जाता है उसमें किया था। उसके बहुत समय बाद जो है रोल्स ने 1691 में इस रिजल्ट को और विस्तृत किया, और जो उनके नाम से हम सब लोगों को पता है, एंड दैट इज नोन एज रोल्स थ्योरम। Okay, or just in this reference again, the same work was revisited by scientist, and he is the very famous mathematician in mathematical world, that is Louis Cauchy. तो लुइस कॉसी ने 1823 में मीन वैल्यू थ्योरम को और ज़्यादा एक्सटेंड किया, और उनके नाम से उनको क्रेडिट भी वर्ल्ड लेवल पर जाता है कि उन्होंने मीन वैल्यू थ्योरम में अपना कंट्रीब्यूशन दिया। एंड देन एट ए वेरी लेटर स्टेज इट इज आल्सो कैपिटलाइज्ड बाय लैग्रेंजेस। तो देयर आर this Lagrange's mean value theorem is the contribution of three great mathematicians, and the perception was conceived by our ancient Indian mathematician Parmeshwara. This is the picture of him, and then Louis Cauchy, and then Lagrange's itself. Okay, so this is always how anything is being invented. That is the contribution of many people in that particular area. So let us look what is the statement of Lagrange's mean value theorem. If you go through a statement, then you will find if a function f(x) is continuous in the closed interval ab, it means continuous at each point in the interval ab, including point at a and b, and differentiable in the open interval ab, excluding the point a and b. Then there will be at least one point c which is laying between a and b, such that f dash c is equal to fb minus fa by b minus a. So this is the statement of Lagrange's mean value theorem. If you go through geometrical interpretation of Lagrange's mean value theorem, then you may say if this is the y is equal to fx is a graph, then it is easy to see that in this graph y is equal to fx is continuous from x is equal to a to x is equal to b, and differentiable within the closed interval a and b. So here you can see according to Lagrange's mean value theorem, for any function that is continuous on closed interval a to b and differentiable in between a and b, then there exists a point c, and in the interval ab, such that the secant line, this is the secant line, the joining means this point is afa, this point is bfb, the joining of these two edges is called the secant line. So this secant line is parallel to this tangent line, the end point of the parallel to the tangent at किस point पर c पर. So this is geometrical interpretation of Lagrange's mean value theorem. If you revert the graph, then it will look like this. If this is the function y is equal to fx, then this line, secant line, is parallel to the tangent line. Okay, another form of this statement is if a function fx is continuous in the closed interval a to a plus h, a and a plus h are in neighborhood, they are very close to each other, and differentiable in the open interval a to a plus h, then a value b is lying between 0 to 1, and f of a plus h is fa plus h times f dash a plus bh. Okay, so this is known as slope of the secant. हम जानते हैं slope हम निकालते हैं ना कि y2 minus y1 divided by x2 minus x1. So that is called the slope, and this is the slope of tangent line, and this is the slope of secant line. The slope of the tangent line is equal to slope of the secant line. तो जो हम जानते हैं m1 is equal to m2, that is the line parallel. तो दोनों line क्या है? Parallel है. So this is very clearly visible about, and you can also say that Rolle's theorem is the special case of the mean value theorem, where fa is equal to fb. So that is in a special case of the mean value theorem. So you can see what is the connection between all these theorem. Now there is a one problem, find c of the Lagrange's mean value theorem for the function fx is equal to, अगर ये polynomial है in the interval 1 to 3. How you can? So first of all you can find out the f1, f3 and f dash x, means differentiation of this, and a and b is already given 1 and 3. It will look like this. f1 is 15, f3 is 49, f dash x 6x plus 5, and a is equal to 1, b is equal to 3. So how you can find the c, means just apply the Lagrange mean value theorem. F dash c is equal to this, and in this way you find the 6c plus 5 is equal to 17 and c is equal to 2. So in this way you find the value of c, which is lying between 1 and 3. Now, if it is second type of the problem, if it is asked to verify Lagrange's mean value theorem, then you can verify here fx is equal to, you can write and then you can find f